Hi everyone. Today we'll be discussing the LeetCode problem of the day. Avoid flood in the city. In this question, you are given infinite number of lakes, which are numbered 1, 2, 3 up to infinite, and you are given a integer array rains. In this integer array, you will have few numbers. So suppose if you have for a particular day, if you have the number 3 here, that means it will rain on the third lake. So initially all the lakes are empty. So if it rains on the third day, if it rains on the third lake, the third lake will become full, and after some time, if it again rains on the third day, this full lake will be overflown. So it says that if the if rains of I greater than 0, that means there will be rains over the lake rain I. So this value of 3, this is greater than 0. That means on the third lake there will be some rain. And we can also have a case where if the value is 0, that means on this day there is no rain. And when there is no rain, you can choose any of the lake which is currently full, and you can go and empty the lake. If rains of I is 0, that means there is no rain on that day, and you can choose any one lake which is already full and you can dry it. So once you have this array, you have to return another array of the same size where if the current day has a rain, then just return -1, and if the current day is 0, then you can choose any lake to dry it. So in this example, first we have the rain on the lake 3, so we don't do any operation, so it is just -1. If rains of I is greater than 0, then answer of I will always be -1. But if rains of I is 0, that means on this day there is no rain, and you can choose to dry any lake. So in this example, we can choose to dry the lake number 3, so that the next time when it rains on the third lake, it won't overflow. So here it will be -1. Also, note that if a lake is already dry, you can if you choose to dry it again, then nothing changes. So that means, suppose you have an input like this. So in this you can choose any lake. Suppose if I choose to choose lake 5, so lake 5 is empty, so if I try to dry it, it remains same, so there's no change. And if there are multiple valid answers, you can return any of them. And if it's impossible to avoid the flood, then you just have to return an empty array instead of all the values filled. And this is what we discussed before. If you choose a dry lake, if you choose to dry a full lake, it will become empty. But if you choose a empty lake, then nothing changes. Now let's quickly look at the examples, so the problem will be a bit more clear. So yeah, again we have infinite lakes, 4, 5, 6. Initially all are empty. Empty. And you have the rains array as follows: 1, 2, 3, 4. So on day 0, the lake 1, it will rain on the lake 1, so this will be full. And whenever there is a rain, that particular day you just have to return -1 because you are not doing any operation. And again, similarly on day 1, it rains on lake number 2, so this will be full and you don't do any operation. Again here on lake 3, this will be full, again no operation. And finally lake 4 will be full and no operation. So at the end of all days, we see that no lake overflows, so this is what we return. The output will be all -1. Now let's see the second example. In second example, initially all lakes are empty and the rains array is 1 2 0 0 2 1. So on the 0th day it will rain on the lake 1. So lake 1 is currently full, and on day 1 it will rain on lake 2, so lake 2 will also be full. Now we have 2 empty days. So on these 2 days there is no rain, so we can go and empty any of the lake. So we won't fill this yet. So let's see further. So on day 4 it will again rain on the second lake, but we see that lake 2 is already full. So if we don't empty this lake before this day, it will cause an overflow and we have to return empty array. But since we have a dry day before, so on this no rain day, we can try to dry the second lake. So here the output will be 2. We can also choose this. So there can be multiple answers. So we'll try to pick the first dry day available. So we will pick this no rain day to dry the lake number 2. So once we are at this day, we are drying the lake 2. So the lake 2 will now become empty again. So when we reach at this point, this lake was initially empty. So we will again fill it because it will rain. And here we'll have -1. Now similarly here we have 1. So 1 was already full, but if you see here, there is also a no rain day. So we can choose to dry the lake 1 on this day. So when you are at here, you are drying the lake 1. So the lake 1 will again be empty. And on this day, you can again just fill the lake 1. So it will be -1. So this will be your output. So if you want to see the day-wise process, so on the first day, what happens? You will just fill the lake 1. The second day, the lake 2 gets filled. On this day, you will empty the lake 2. And on this day, you will empty the lake 1. And on the next day, you will fill the lake 2. If you fill it, then you just have to hit -1. And on the last day, you will again fill the lake 1. So in every step, we see that no lake overflows. So we just return this array. And finally, let's see the last example. Again, let's write all the lakes. Initially, all are empty. And the rains is 1 2 0 1 2. So first lake 1 is filled, then lake 2 is filled. Now here we have 0. So as of now we won't do anything because we don't know which lake we want to empty. Now when we are here, we see that lake 1 is already full. So that means we should have emptied the lake 1. So in this 0, we will pick lake 1 to be emptied. So lake 1 was full, and in this no rain day, we are emptying the lake 1. So that on this day, since it will rain again on lake 1, it won't overflow. So since it's empty, this will again be full. But here, if you see, it is raining again on lake 2. So we can see from here that lake 2 is full, and there is no way we can dry both lake 1 and lake 2 because we only have one no rain day. So because lake 2 is overflowing, we will just return an empty array. So for output 3, it's just an empty array. Now let's go over the approach. For example, if we have this rains array, so lake 1 will be filled, lake 2 will be filled, and this is a no rain day. Here lake 3 is filled, here lake 4 is filled and the no rain day. Now we can see that lake 2 is repeating, so we have to go to any of the 0 and dry the lake 2. So for 2 we have two choices. Either we can choose this dry day to dry the 2 lake number 2, or this. So if we choose this day to dry up the lake 2, so on this day lake 2 is dried. So when it rains again on lake 2, we'll just fill it. Now again we have the lake number 4. So lake 4 is full, so we have to choose a day after lake 4 is filled to dry it. But we can see that this 0 is already taken up by 2. So we can't dry the lake 4, even though this 0 is empty, so we haven't dried up any lake. We can't use it to dry 4 because the lake number 4 is filled after this day, so we can't go to a previous day and dry it. So we can't dry the lake before it filled, right? So whenever we have a choice, so for the 2 we have two choices, the first 0 or the second 0. So we should always go with the first 0. So we have to greedily choose the first possible dry day to dry it, so that for next elements we will have more options because the day is going progressively. So in this example, if we chose this day to dry this, so here we will fill the lake 2, and when we want to fill the lake 4 again, on this day we will dry the lake number 4, so that here the lake can be filled once again. So one thing, whenever we have an element repeating, we have to see, so the element is repeating here. So after this day, we have to find the first 0, and we just have to dry the current lake number. So one way we can think of is brute force. So just maintain a map of the days. So lake 1 is filled on day 0, lake 2 is filled on day 1, then this is a free day, then lake 3 is filled on day 0, 1, 2, 3, and lake 4 is filled on day 4. Now when you are at here, you see that 2 is already present in the hash map. That means it is already full, so I have to empty it. I have to dry it before filling it again. So from the hash map we can see that when was the first day this 2 was filled. Let me also write the index here. 0, 1, 2, 3, 4, 5, 6, 7. So the value of 2 is 1. So on day 1 the 2 is filled. So all you have to do is iterate after the day 1 till the current day, and we just have to find an empty 0. So we can see here we have an empty 0 slot, so just fill it and update the map. So that means the lake is filled, here the lake is dried, here again the lake will be filled. So the key of the 2 will be 6, because this is the last day the lake was filled. But by doing this approach, whenever we have a duplicate, we are again iterating kind of the whole array to see the first available 0. So in the worst case, the complexity will be order of n square. And if we quickly check the constraints, yeah, n is 10 power 5, so n square will be 10 power 10 and it won't pass. So we have to somehow optimize the code. So the approach will remain same, that whenever you have a rainy day, you add it in your hash map, and when you have a duplicate, you want to find the first 0 that can be used to dry it. So what we can do is, whenever it's a rainy day, we are filling it in our hash map to know when was the first day it rained. But whenever we have a free day, we can include it in a tree set. Tree set. So the second day is a free day, and 0, 1, 2, 3, 4, 5. The fifth day is also a free day. So when we are reaching this two, this is our hash map so far, and this is our tree set. So from our hash map, we can see that on day 1, the lake number 2 is filled. So we have to check after this day 1 that if we have any empty zeros or not, we have any free days or not. So if we see from the tree set, the lake number 2 is filled on day 1. So from this tree set, we want to find the first number which is greater than 1. So for the tree set, we have a property that if we do set dot higher, and if we just give a key, this will return us a value in this tree set which is just greater than the key. So here if we just pass set dot higher of 1, so it will go and check in the tree set the first value which is higher than 1. So it will go and fetch this 2, and it will do this operation in logn time. And also insertion and deletion in the tree set is also logn time. So when you're at this 2, you will check for set dot higher 1. So this will return you 2. So that means on the second day, you have to use it to dry lake number 2. So here you will fill 2, and once you do this, you will remove this 2. So you will do set dot delete this 2 value, and you will proceed. And also you will update the key, the value of this 2, 0, 1, 2, 3, 4, 5, 6. So it will be 6. And finally, when you reach 4, again you will do the same thing. You will try to find when was the first day the 4 was filled. So from this map, you can see 4 is filled on day 4. So you will try to find set dot higher 4. So from this tree set, it will try to find set dot higher of 4, which is 5. So that means on day 5 is used to dry the lake number 4. Now suppose instead of 5, here we have 3. So that means it is something like this. Okay, what was the 3 and 0? So in this case, we can't dry the lake number 4 because after 4 we don't have any zeros. So if we try to do set dot higher 4, it will return us a null value because we don't have any number in this tree set which is greater than 4. So if set dot higher is a null value, then that means we can't use any day to dry the particular lake. So we just return an empty array. Now let's quickly code it. So first let me take in range.length and also an answer. Its size will be the same as the range. So initially I can just fill the answer with all -1 because if it is a rainy day, then on that day we just have to return -1. So to just make it a bit easier, I'll just fill the answer with all -1s. Arrays.fill answer -1. And let me just initialize a tree set. And also a hash map. tree set is used to store the non-rainy days, and the hash map is used to store the first day, the previous day that it rained on the same lake. Hash map. Now let's just iterate. So first, if we have rains of I equal to 0, that means if it's a dry day, what we do is we add that particular day in the set.add I, and currently we have all -1, so we'll just set answer to be 1. This value can be anything, because if we need this day, we will just replace this value, but since it can't be -1 because the lakes are starting from 1, the lake number will be start from 1, so we will fill 1. This value can be anything, it can be 10 or 100 as well, so let's just keep it 1. Else means it is raining. So first let's check if it is repeating or not. So if map dot contains key rains of I. If map dot contains key rains of I, that means it has already rained on a previous day. So let's just find on which day it rained. Rain equal to map dot get rains of I. So once we get the last day it rained, we need to find a free day in the set which is just greater than the last day. So integer free equal to set dot higher last rain. So this will find just the greatest value which is higher than the last rain in the free set. So if it was not able to find it, that means if free equal to null, then the lake will overflow. We'll just return an integer empty array. Else in the sense we found a day, so that means on that free day we will use it to dry the lake rains of I. And once we do this, we are using up that free day, so we'll just remove it from the set dot remove free, and at the end we will update the hash map dot put rains of I, I. If map dot contains, we will do this. So here we can just do map dot remove we don't need to do this because anyway we will be updating the value here, so we don't need to remove again. And at the end return answer. Let me submit. Yeah, and it works. Also, like I said, we can use any day here to be the free day. So if we don't need to dry a particular lake on this day, so we can choose any random lake to dry it. So if it's already dry and we choose to dry it, so nothing changes. So if I just try to submit again, and it will pass. So this value can be anything. It's just a placeholder value, so that in future, if we want to free any of the lake on that day, we will update this value. Finally, let's do the time and space complexity analysis. So for the time complexity, we are iterating on the rains array, and in that we are getting the value from the map and also updating it, that is login. And also the same thing with the set, we are inserting, deleting and getting the higher value, and that is also in login time. So the total complexity will be NlogN. And coming to the space complexity, we are, apart from this answer, we are initializing a set and also a hash map, and the size can go at max n. So space complexity will be order of n. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.